Hello everyone. So in our last class, we explored a glassdoor dataset. So we were trying to clean so many columns. We did a lot of cleaning, and after cleaning, in case you want to check, you can check the previous video. After cleaning, we removed some textual data from few columns, and we created some new columns. So the new columns were like average salary, min max salary, job state, company age, and some Python R, Spark job, AWS job, Excel job, and we simplified the title of the job as well, and we created, I think, the column job seniority column was also created. So few columns we have added and a bit of cleaning. Yeah, you may go through with the previous session to check this. Now let's move ahead a bit of the exploratory data analysis part. So we will try to do some visualization here. So I have imported matplotlib seaborn, and first I'll check the statistic summary of my data. So I have applied df.describe, so I can see for all the numeric columns the standard deviation, the count, and the mean, and some lower upper quartile and the max value. So we can check from here, and we see that there is not so much, nothing as such we have for all the newly created columns, as the min value was 0 mostly, and lower upper quartile and all. But we do have count, mean, and standard deviation for those, and the min and max. So we get bit idea of our data set, and then we move ahead, and we created a histogram for the rating, so that we can see that what is the average rating that is provided to the any of the company that we do have in the database. So we simply, what we did for creating this histogram, I mean the column that we have selected, and simply applied histogram, and then the label that we have given and the title for this particular plot. So here, I mean, this is something like a rating. We can see it's a few minus values also there, and the rating starts from, I mean, mostly it's upper three, like rating in terms of the count is, majority of the count is between 3 to 4. We could see. So these are the counts which is more than 250, and this is the rating range that we could see. Now we'll see the distribution of data for the company age, so that we can get the idea that how old the company is, and the maximum maximum count for a particular company, the majority of the age of a particular company, I mean the time in years, we have already calculated from the founded, or when that company was founded column. We calculated from the current year to 2022, we calculated the age and stored that into company age column. So we are getting that value here. So the company is, we could see time in years, the companies are there less than 50 years, we could see. The majority of the companies lies in this area, is this range, more than 350. And then we have some old companies also available. I mean, we could see that is there in the data, the 150-year-old company, 100 years, and till 250, or even few data points are there even more than that. So that's what we can see. And then we see the average salary, the distribution of the salary for this particular data set, and that is like annual salary. It's, you could say that it's kind of a, not properly, but it's kind of normal distribution. I mean, the majority of the salary lies into this range, and I mean towards the lower side and toward the upper side. So we do have the data points. I mean, not so skewed data is available for the average salary part. So that's what we could see here. And we could create a box plot as well. So box plot is like we could see the whether we do have outliers or not. But box plot create a direct outliers, but sometimes it happens that we get in touch with the the domain expert and the business owners to get the idea, like what are the extreme points then that we could take, I mean, the lower side or to the upper side. So box plot has given you the idea. We see that we do have some outliers towards 200 plus is average salary. Beyond this area comes under the extreme data points. And this is like, we could say the interquartile range that we do have. And the majority of the data lies into this range. So we can create a box plot to get the idea. And we did the same for company A's. For company A's, we have, I mean, some extreme points available to this, the upper side of the direction. So we have this. And we have created these box plot using Seaborn. So I have used sns.boxplot, and the data that directly coming, that is DF, and the column that people are using, orient like vertical or horizontal, and for palettes and all, either you define or not. So it will take the by default one as well. Right, and then we were trying to find the correlation between the columns, the company age, average salary, and the rating. So we selected these three columns and tried to correlate them. So here we see that not so good correlation is there. It's not very much correlated. We tried to plot that as well. So using SNS, we have plotted, and we see that this is, we put it into the form of visuals, the correlation that we do have. So the darker the color, the higher the relation, the lighter the color, the lower the relation that we could have. So we see that there is no I mean, correlation found as such in terms of company age and salary and the rating. Now we are going to explore the categorical data. So to see that, first we are trying to find the all columns that we do have in data. We see we do have job title, salary estimate, and so many columns. Some new columns we also have created. And I mean, we decided, we picked some columns, like these columns we have created. What you could do, you can simply use df.dtypes, so that you can get the types of the columns as well here. So we have selected from a few object or the categorical type columns from here, like company name, location, headquarters, size, type of ownership, industry, sector, revenue, job title simplified, and job seniority. So these columns we have selected, and we basically we are going to plot the data for location and headquarter columns. So these two columns we have created so that we can see what is the location and the total value till 20th count, like total 20 records we are going to showcase. So we have applied the value counts on these location and headquarter, the columns that we do have, and then we are trying to showcase the total 20 records. So that this is the graph. So we can see that for the people who are there mostly lies into the New York and San Francisco. So, and we could see then the number of occurrences that is going to, these are decreasing towards this direction for Dallas, and for equally people are mostly lies here, but the majority of the location that we do have, that is to these three, the higher the bar, the more the data that we do have. So we could see that part here just to visualize. And then we have graph for the headquarter, and the previous one was for the location. So for the headquarter, we could see that for the total occurrences that we do have for a headquarter column. So people are there into the headquarter of that particular organization or a particular different locations. So every company do have one base location, and then they have different branches, or could see that some other locations they do have set up. And now we are going to plot the data, and the columns that people are using are the company name, the size, and the type of ownership, and the revenue that they do have. So we have plotted it so that we can have the visuals impacts as well. So total 20 records we are using, because more than that records, it's tough to visualize into this plot. So we see that these are the company name and the total, into the entire data, how many people are there in these companies. So that's what we could see. And then the currencies of the companies that we could say. So that's what we can see. And then we have the size of, the total, the range of the employees that is available there. So what is the size? How many companies are there that lies into this range of employees? So like 1,000 to 5,000 are there for the blue one, the first bar, and so on. So we could see something like that. And we have two unknown and unknown known applicable values also available into this column, so we can check that part too. And that is for the ownership. So for the type of ownership, we could see that mostly companies are into working as a private sector and then public, and the very less data that we do have for school and the other organization, and the college, university is also less, hospital, government is also less. The majority is into the private and then the public one. That's what our observation. And then we have plotted based on the revenue. So for revenue, we have mostly the data that we do have lies into the unknown and known applicable, and then 10 plus billion USD, and it goes on till less than 1 million USD, right? So we have something like that. So we plotted this, in a same graph we plotted. So we directly applied a for loop and selected the columns, and then we have put it. And these are, in case you are not able to find what to fit into these variables under this, let's say sns.bar plot, so you can simply use shift plus tab. So you will get all the options and the description as well, kind of a help you may get from there, right? Here like this. So it's very tough to remember all those, but using shift plus tab, you can get all the related functions we may apply here, or the values that we could utilize. So you could do something like that. And then we are plotting the data for industry and sector as well. So the same way we applied a for loop on these two columns, and we have taken 20 records into the consideration. And here we can see the graph for industry. So there are different domains, you could say, or the industry. So the majority of the data that we do have into the pharma and the insurance sector, and then hardware and software and so on. The list is quite big. So that was our observation. And then for the sector we do have, so we could see for the information IT, we have almost 175, more than 175 occurrences, then to the pharma, and it goes on. And it decreasing till different sectors that we do have. Now we are going to plot the data for the job title, simplified, and job seniority columns. So these two columns that we have created. So for the job title that we simplified, that was data scientist, and one category was there as NA, and the data engineers, then analyst, and the managers, and the machine learning engineers, you could say, and the director. So we do have majority of the data that we do have as a title, that is as a data scientist, right? Which is more than 250 records are there. And then the job seniority, we have created the junior, senior, and not available category based on one of the column there in the raw data set. So we have the majority of the data as a job seniority is not available into the not available category, then into the senior one, and very less is there as a junior. Then we have again checked all the columns available, and then we are going to apply a pivot table, and we are going to use job title simplified and the job seniority, so that we can see that under each and every category of job title simplified, the label of the seniority that we do have and their average salary. So we are going to plot it so that we can get the idea. And based on it, we could see that under job titles simplified, we have analyst, and under analyst, we have these categories as a job seniority, and these are the average salary we have for all the categories. And we have data engineers, data scientists, director, manager, MLE, and their job seniority and the average salary that we could see. For director and manager, there was no job seniority data was available, because that was that lies into the category of not available. And then we have under not available as well, the we could say the title under job title, we have not available also. In that we have senior and not available. So something based on the data that we basically summarize it in terms of like, so that we can get the idea for all the titles, under all the titles, what are the profiles and what is their average salary. Now next, what we are going to do, we are again going to plot it, create a report, a kind of a customized summary that we want to have, that is for the job state and the job title simplified, so that we can get the idea, what is the average salary for all the job profiles to a specific state, right? Something like that. So we created like job state. These are the states, and under those states, the different titles that we do have, and then with their average salary. So something like that we could see. And then based on the job state, directly we see the average salary. And here we see that state-wise the average salary. The profile doesn't matter. Based on the state, we could see that average salary that particular state is providing based on the data that we do have. Now, basically what we have filtered the top 15 industry. We sorted and we have taken only 15 values, and we have find out the average salary. So we can see that top 15 industry, they are providing the highest salary, we could say. So the highest salary that we are getting in the other retail stores, which is the maximum one, and then it goes to the motion picture production and distribution, then financial analytics and research. Then some other categories are also available under industry column and their average salary, so that we can get the idea. One observation that we do have, we missed to handle this record, so that should be handled here. So you may handle whatever. We tried to remove the other columns previously, so you can find any approach to remove this part. So that kind of a data error which is available there. Now we see the top sectors for data scientists. So what we did, we have selected the different sectors and their average salary, so that we can see that is there any variation to the salary, specifically like you working for the IT, then the average salary is this. If you're working for the accounting and the pharma, what is the average salary? So we see there is no major differences. That's what we can see. That is 113 point something. That same goes to accounting and legal, and then unknown non-applicable category, and media a bit higher, and that is bit lower side. But still we could see that the distribution of the salaries to all the sectors somehow quite similar. So there is no difference, like whatever the sector you're going to join, it doesn't create any impact for your take homes and all. Right. So that is our observation from this. And then we see the top company type that pay data scientists well, so that we can see based on their ownership, the public or the private sector or the government sector or the educational related college and some NGOs or something like that. So we created a pivot table based on the type of ownership and the average salary, and we picked only few data points, and like 10 data points we have picked from there. So we picked the ownership and the average salary, and we picked total 10 records. So we see so there is also, we could see there is no major differences between the private university and the business segments and the public. So they're almost quite equal. And then if it goes to the government and the other organization is school, college, and the lower average salary that we are getting under the hospitals. That's what we could see. And the other, like the companies, that was the basically previously we did for the ownership, the different sectors, and then we're going to get the average highest salary based on the company. So we created a pivot table based on company and the average salary, and sort the values based on the average salary, and pick top 20 companies to get the idea like how they're paying to the data scientists and all. So this is what we can see. And here also, that is the observation, whatever the company there is no huge difference in terms of the average salary that we could see here, right? Yeah, so that is also the observation. No major differences we have observed. Now, that was a bit analysis, that bit visuals, that we get the idea and some understanding of the data. Now we are going to do the feature engineering. So because we could see we have so many columns, so we need to trim some columns as well. So we need to select that how many columns are required. So we see, because if in case we do have unlabeled data, so we have to label it, and for labeling it we do have multiple way of labeling. Like we could use the dummy variables, we could use one hot encoder, and we can simply assign some values to the categorical features and all. So we are taking top 11 industries, and so we have created a list of the industry here. I suggest you, in real times when you're working for any particular project, so to get the idea what is the top 10 industries and all, we need to sit with the subject matter expert or the domain expert to get this idea. Being a data scientist, we are not very expert in every industry or domain. So those are the people, or these SMEs are the people who give the better idea to you. So based on the discussions that you do have with them, you can select the values like the top industries, and then we can do further trimming of your columns, right? So we did it, like we have created a list. So here we have simply created, and that's what based on the discussions. But here I have put it as per my understanding. I have put a few industries, and then I taken on only 11 industries from there, and other I have put it as into the one category, which is other. So this time we will be having total 12 industries in that column, right? So in case, before trimming it, in case I check it, let me insert a one column above. So if we see, let me put DF. Total unique records under this. Let me buy and unique. So there was 12. So we have taken 12 industries. I think data we have already run the entire data. Otherwise, it is going to be more than this, because I have already run the entire files. So that is already done. So it must be more than this. So there is no use to find the n unique here. So we put it only 12 industries into this and created a user defined function, and we applied on this column so that we can trim the extra columns under extra values under industry column. Now we are going to trim the job state column as well. So we have taken only 10 states, and then apart from these states, anything which is coming there under state column, we are putting into one category, which is others. And we did the same. So here also we have created total 11 records under this job state column. Then we have, we are going to add column for job in headquarter. For example, the location, the person who is working as a headquarter. So we have put it a new column so that we can identify that person is there in headquarter. And then we have created a, put it into the if and then the else, and then it goes on. And we have selected the columns to see that how many columns we still have, and we have selected the relevant column. We create a copy and put it into the df-ended model, and these are the columns that we have selected, right? And then here we are going to rename it. There are multiple way to do it. In case you want to rename, I have just put it a rating as a company rating, size as a company size, type of ownership, revenue, and some other values that I have renamed here. And don't forget to apply in place equals to true, otherwise it will not make change to your original data. And then again, I see that all the changes are applied here for the data set, and now my data frame is like df_model. Now we need to handle the ordinal categories. I hope you understand the ordinal. Ordinal means where we do have some mathematical meaning. So for example, we have the company size. Under company size column, we have data something like 1 to 50 employee, 51 to 200 employee, 200 to 500 employees, something like that. So what we are going to do, we are going to label it based on the, like our understanding it into the increasing order or into the decreasing order. So we understand that unknown is 0, and 1 to 50 we have put it a label as 1, and 51 to 202, and so on. So we have created like total 7 labels for the existing unique records that we do have under company size. So we applied it, and we have basically created we mapped it, and we have created a company size rank column after labeling it. The existing column was company size, and we have created new column based on company size, and which is company size rank. So we labeled that. Now we don't require company size, so we have simply dropped it. So here we applied a drop, and on access we can apply access 1 or access 2 as well, and in place is 2 there. Now we need to do the mapping for the revenue as well. So the revenue is itself is an ordinal column, so that is do have a mathematical meaning, like the revenue less than 1 million or greater than 1 million or lies into a specific range. So that is also the ordinal feature. So we put some labels for these categories as well manually. And then we have the same thing we applied here, like we did for company size and rank. So company revenue rank we have created after labeling it, and then we dropped the existing revenue column. So because we don't require it, so we dropped it. Now the same thing we did for job seniority, because seniority also the ordinal one, like if it is junior, then it is lesser than the senior. So that do have a mathematical meaning, and NA we put it as no meaning, like 0. So we have mapped it, and we again drop the job seniority, and after creating a job seniority rank column. So you can give any name. I just put it rank, or the labeled one you can give. So that was we did for the ordinal data. Now coming to the nominal categorical features. Nominal means where the class different categories we do have, but they don't have a mathematical meaning. Whatever the category we can put, it doesn't makes any difference. So for nominal and categorical, I just give one example here, nominal and ordinal. So let's say you have put it BTech, MTech and PhD. So we do have 3 different categories, and the other we have, for example, okay, that's green, red and white. These are the different color names. So that these 3 categories do have a mathematical meaning, some weightage. So that is ordinal. And here we don't have any mathematical meaning. Either we do have green or red or white. We can't say that red is greater than white or lesser than red. So that comes into the nominal category. But for this part, for the ordinal part, we could see this. We could say that BTech is less valuable than MTech, or in terms of the number of years of experience that you do have, or PhD is less is more do have more weightage than BTech and MTech, something like that. Now we need to do the handling for nominal categorical features. So we can simply apply our dummy variables. So that we did. So so we did for the type of ownership column from this data frame, we applied get dummies, and now our shape is going to be increased because the total number of unique records that we do have under type of ownership, that many columns you are going to create using get dummies. And the same we did for industry. And now earlier we were having 24 columns. After applying this, then here we have 35 columns. So we see 11 categories are there in the industry. So with the help of get dummies, we are going to create a column based on the unique categories under that column, right? For job title simplified as well we did. Now our shape is 41. So the total columns that we have created till here is 41. And same goes for the job state. Get dummies, we applied, and then we check the shape. Now total 51 columns we do have. Now we need to do the feature scaling, and feature scaling we just seen a data. That data we do have, we see that we have almost convert all the columns as the numeric columns or the labeled one. So what we do first, we check whether we do have any missing or not. In case we missed, we noticed that previously there was -1 value was there. So we are not going to take any missing value into the consideration. Might be we don't have. In case we have, you may handle it another way, but I simply dropped it. So you can try another way to solve it based on the column value, but I simply dropped because there was only one column, so I dropped that. Now we have extracted or defined a target and independent features. So we have X as independent variable and Y as a dependent one. So in X we consider all the column except average salary. which is a target variable, and in Y we have put it average salary. So next, everything after dropping average salary, and in Y just average salary. So we put it that as well. Now we are going to use sklearn pre-processing to min-max scalars. We are going to scale a data as well. So to scale, we have defined the columns like company rating, competitors, company age, company size, and few columns are there. And then we fit into use the min-max scalar. The object that we have created was the scalar one. I hope you clear with the min-max scalar. If not, let me know into the comment section so that I can create video, a detailed video, explaining these parts. Now we used a fit transform and pass these columns into it so that we can scale those columns, and we put it that as a columns to scale in X. So all the columns are there. Now the next thing that what we did, we have imported a train test split because we need to split the data into the train and test sample. So we have taken a 80-20 ratio and then we the total number of records that we do have into the training data, and this is our training test data size. Total 50 columns are there because 51 was all total column, but one goes as your dependent variable. Now we are going to do a model building. So for model building, basically what was your the dependent variable? That was your average salary, which is a basically a continuous numeric. So whenever we have a continuous numeric column as a dependent variable, so that comes under the regression problem. So for solving the regression problem, we need a regression algorithm. So we are going to pick a linear regression one. So we have imported and created a linear regression object, and then we fit our train and training data into it so that we can fit our model. And then same we did for the decision tree. And then from sklearn itself, we have imported another algorithm, which is decision tree regression. And for the criterion, MSC and the max depth 11, we have put it in case you want to understand the meaning of why we have taken these variables. We can have a detailed session on it, or you can simply go through with the official document of decision tree regressors so that you can get the idea from sklearn itself. Then we fed the data here under the decision model, and we have this training set, and this is our test set, the 94.1% accuracy that we do have for the training, and the 38.1 is for the test one. And then we can apply the same for the linear regression as well. I think I have commented that part, sorry. So we see for the accuracy of the linear regression model on training set, that is 58, which is not so good, and for test set is 57. So equal is there for training and test. And for decision tree, we could see that for training data, that is 94, which is good, and for test, that is 38. And then we go for the random forest regression, and random, after creating we just imported and creating an object, and we fit a model. It's quite simple. For all the algorithm, we need to use the same approach to fit the model. And then we have calculated the accuracy. And the accuracy, how we have calculated, we can see that this is a way for calculating it. We have calculated basically a percentage. Otherwise, you can use some other way as well to get this idea. I mean, for the random forest regression, we have training set accuracy is 94 and test says is 75. I think it is the better than the random for the decision tree and the linear regression. And then we have picked the EDA boost, and using EDA boost, we have the accuracy, which is 96, and the test set, that is 77. So we have applied EDA boost, we have applied random forest, decision tree, and linear regression, and we could see we get the better accuracy into the EDA boost one, and the second one is the random forest regression. So further we can do some more, we can reduce some more error, and we can do some more enhancement to the model that we have built. But this is just a very basic way for creating a model and to fit a different algorithms, and then we can predict. And to get the prediction, you pass all the possible combinations of your X, and then it is going to be predict that what would be the average salary for the all the combination that you have passed as a independent variable. So this is how we have created. This is one of the way. I hope you get bit idea how to do it. The major concern of getting this data set is to let you know that the different way of cleaning the data. Our major focus was towards the data cleaning and the feature engineering. That's what we did here. I hope you have a good learning over it. In case of any confusion, any questions, feel free to write into the comment box. Thank you very much. Take care.